Yeah, we have been discussing about various experimental techniques. What is the physical principle behind the experimental technique? What are its main features? And also in which class of problems these techniques could be ideally used. And we have discussed the method of caustics in the last class. And when you look at each of the techniques, there are pioneers who have made significant contribution into the development of these techniques. Professor Kalthoff from Germany was a person who has worked on caustics and made it to its perfection, and there have been contributions from Theocharis and also from Rosakis and his group at Caltech. So, many scientists have contributed to development of each of the techniques. If you look at any technique, if you look at strain gauges, if you look at holography, these are all not developed by a single individual. Someone identifies the physics behind it and the idea is initiated, then people carry on and many scientists contribute to it. And what we saw in the last class was, we had seen at the tip of a crack you have a nice caustic shadow obtained, and we explained how this shadow is formed, and we also looked at that the silver line what you have is the caustics, and in actual experimentation you just measure this diameter, and then you have equation which will help you to find out what is the parameter associated with this problem. In this case, you will be able to find out the stress intensity factor by measuring the diameter. And I said caustic is not a general purpose experimental tool, it is only a high stress gradient problems you get information from this. And what you find here, you do not have any information in the shadow region. So, this prompted researchers to find out how to fill in information even in this zone. And if you really look at the method of coherent gradient sensor, that is what we are going to discuss next, that has originated from this aspect in mind. And what you have here is, it is a double grating lateral shearing interferometer providing whole field fringes in real time. So, we have emphasized some of these concepts. We have said whenever you look at an optical technique, you have to find out whether you get information in real time. If you get information in real time, it makes your life lot more simpler. And we have seen any technique which involves double exposure, you need to do post processing, and only then you see the fringes in real time. Whereas techniques like photoelasticity, Moire, you do see fringes in real time. On similar lines, you also find coherent gradient sensor gives you fringes in real time. And here the optics is little involved, and also the principle is also, the mathematics are quite involved. So, what we will do is we will have a bird's eye view of what this technique is. And what you find here is, you have a light, if it is opaque model it gets reflected from the surface, if it is a transparent model it gets transmitted, and you are really looking at the distorted wavefront, and you look at the distorted wavefront and you find out the direction cosines of the object wavefront. This is what you essentially do in the optics, and this has different meanings when I do a transmission arrangement or when I do a reflection arrangement. So, what you find here is, in a transmission arrangement I relate these to the gradient of the sum of principal stresses. So, this is what I had said, for each of the techniques what you find here is, there is a physics is exploited, and that physics dictates what is the information you get from interpreting the fringe patterns. And here what happens, you are able to get those direction cosines related to the gradient of the sum of principal stresses. This is what happens in a transmission arrangement, and when I go to reflection arrangement, what I get this, I relate this to the gradient of the out of plane displacement. So, we have seen a very similar parallel information when we are looking at holography. What we said was, I can find out essentially out of plane displacement, and in fact, when I want to combine photoelasticity and holography, I exploit the feature of holography to measure the change in thicknesses because of Poisson ratio that is related to sums of principal stresses that we had looked at it. So, they go together when I have out of plane displacement and also its relation to in plane problems, it could be related to sigma 1 plus sigma 2. So, what we find here is I can apply coherent gradient sensor in transmission arrangement as well as reflection arrangement. In transmission arrangement, I get the gradient of the sum of principal stresses, and in reflection arrangement, I get the gradient of the out of plane displacement. I get only a gradient, I do not get actual values, I get only the slope. And what you find here is this has found wide application in dynamic studies. So, if you look at dynamic fracture, Professor Rosakis and his group and Harish Tepur, they have developed this technique. They have found it useful for dynamic fracture studies. So, what you find is in the caustic shadow you lose information. Caustics is not a general purpose experimental tool. On the other hand, coherent gradient sensor, because it gives information on the entire region, this has been used for finding out curvature. That is what we had seen in few classes earlier. We had also looked at the shearing interferometer can be used for finding out slope and curvature, and in a sense it complements the data that is given by caustics. There are also experimentalists who have combined method of caustics and method of coherent gradient sensor to be recorded in one optical arrangement. See, I have been saying, if you have a problem on hand, you may not be able to solve all the quantities that you want by using one experimental technique. You may have to use multiple experimental techniques in a generic sense. I have shown that people have combined strain gauges and brittle coatings, so that they could do and solve industrial problems very quickly. And we have also seen, if I want to find out separation of stresses, interferometric technique and photoelasticity could be combined. On the other hand, people also thought of recording this information simultaneously. Such equipments also have come. One is use and perform experiments separately, then process the information. And once you decide that these are the two information I want, people also devise new equipments wherein they could either simultaneously record or record one after another with the same optical arrangement with modification of what you want to insert. Such a development has also been seen in combining method of caustics and coherent gradient sensor. So, such information available in the literature. In this class, we have started with a brief look at what caustics were. Then I said in the caustic shadow you do not get information. So, you have coherent gradient sensor which provides information in that shadow,